And we are started. Good morning, grade 5. It's Mr. Boolsen here, ready to bring you another math lesson as soon as my camera cooperates. Oh, there we go. It's all up and running. So, anyways, we're going to start right off because I think the best idea with these math lessons is to try and get them out and get all the relevant information down as quick as possible. I'm not going to do a mental math minute because I think your parents can do that with you, or they can do as they see fit there. We're trying to get the main skills down here, while multiplication is quite important. So I do suggest you practice it up if you struggle with that a bit. We can work through this at a later date, perhaps. Okay, so right away, today we're dealing with a lot of multiplication and division, as I said. So the other day we were doing a lot of addition and subtraction problems. Today we're dealing with some more multiplication and division problems. So what we want to start off with is this idea of scale factor. And now this isn't a scary scale monster or some other dragon factor or factor of how many scales will be on you. This is about scales, as in scale like from 1 to 10 or something like that. It's multiplied. So sorry, that was a terrible example, but I will show you here what I mean. It means that how many times greater than something else. So yeah, so I could say that I am 2 times as tall as some of you, and that would be I'm a scale of 2, right? So I don't know if that's entirely true, but I think it could be close. Anyways, I'll show this to you through an example. Sally has 3 marbles. So Sally has 3 marbles. Sam has 4 times the amount of marbles. Yeah, we'll just say 4 times. You'll get 4 times the amount of marbles. So the important thing to note here is the 4 times. 4 times means that he has 4 times the amount of marbles. We've talked about this in past lessons. This is just continuing with this. This is they're using scale factor now as the idea. So the scale factor in this question, or in this this example, is 4. And we'll come back to that in a second, and I'll do some more work here. I'm just going to show you one other example. If we had Glenn, and I told you he is 3 times as old as Nina, that the scale factor here is 3 times. So we'd say the scale factor is 3. So that's just something to remember. If you see times, or basically 3 times, 4 times, 7 times, a bazillion times, that is kind of what we're dealing with. When I think about this, I think of sometimes, they met, if you're thinking, I don't know why I think there's an army sense, they met an army twice their size, or he was twice his size, right? That means he's 2 times as big, right? So that's the scale factor, right? And that's where I get it the most easily. So we have Glenn is 3 times old. So the scale would be that, and if I said he was 5 times as old, then it would be bigger. Now, when we add something here, well, let's go here. So we have 3 marbles, and the scale factor is 4. So how do we figure out how many marbles Sam has? Well, so we know that Sam is going to have more marbles. So what we do is we will multiply Sally's number of marbles, 3, times 4, and that'll give us Sam's amount of marbles, which is 12. And in Glenn's case, if we say Nina, this should be included, Nina is 2, then we're going to know that we have to times Nina's age by 3. So you have 2 times 3 equals 6. So do you see that the scale factor is how many times bigger? Now in your books, the reason why this is important especially is that your books organize it this way. On in question 1A, well, 1, you'll see that this is the way they do it. So this is on page 16 that we're working on, and it's page 17 today. And you'll see that they follow this logic. Now, what we can do here is I can show you something else that if we were given Nina's age and not Glenn's, or sorry, if we were given Glenn's age and not Nina's, so let's say we still know the scale factor is 3, but how about we were given Glenn's age, which is 6? Instead of saying 2 times 3 equals 6, how would we, if we had 6 and then we had this scale factor of 3, we have to do something there, and it equals 2. What are we going to do? Are we going to multiply 6 by 3 to get 2, or are we going to do division? Now, the correct answer is, of course, division. Now, the reason for this, and I'll show you this as in words, that if you are looking for the larger part, and you have the smaller part, so you have the younger one or the shorter one or the lesser one times the scale factor, right? You're going to times it. And we always know when you multiply, except with a 0, I guess, when you're multiplying, your number will always get bigger. So that's why if you have a smaller number and you're looking for the larger number, that might be a way you can remember it. If you're looking for the larger number, you're not going to divide your smaller number. You're going to multiply it. So if you're given the smaller one and the scale, like we were given here with Glenn and Nina, so Nina was the smaller number and the scale was given as 3, then we can find Glenn's age. Now, if you are given the larger number and you're looking for the smaller number, smaller part, you're going to say you're going to take the larger number and you're going to divide it by the scale, because the scale is still, if he's 3 times larger, then you can also divide that by 3 to find his younger sister Nina's age. So I hope you guys kind of see that if you have a larger number, if you're given the smaller number, you can times it by the scale, and if you're given the larger number, you can times it by the scale, or divide it by the scale to get the smaller number. So you see that. And this will come up again in a different way in a moment when we get to sets. I just want to show you how this works with question 1A in your books. You have 21 cats, it says. 21 cats and M dogs. So what do we notice right before I get any further here? What don't we know already? We don't know how many dogs there are. So that is going to be what we're ultimately looking for. And if we say that there are 3 times, so 3 times as many dogs, we are going to be knowing that the scale factor is there, right? 3 times. And we also know that there are more dogs, right? There are 3 times as many dogs. So if it said as many cats, then we know that the cats are larger. But in this case, we know that there's more dogs than there are cats. So what does that mean? Where would the dogs fit in this one? Would the dogs be the smaller one if there are more? No, they'll be the larger one, the larger part of this system. So that means what we are looking for, M, the dogs. And what we're going to do is we're going to take the 21 and times it by the scale factor. And this will give us the M. And if we do our math here for a second, we just think about this, we're going to get a good old 63. Perfect. And that is the M. That's what M is equal to. Great. So, yeah, now if we were given the cats, we would use this one instead, right? If we had 63 as the larger part, so we can work this backwards. If we had 63 divided by 3, and that was for the cats, we'll just say as C, that'll give us the same thing. We'll get 21, and that'll be the cats. And you see, you can find it backwards. So instead, if the question said there are, 63 dogs, and there are 3 times as many dogs as cats, how many cats are there? So you can just divide the amount of dogs by the scale factor. And that's what it's looking for in question 1. So without further ado, I want to continue on so we can try and keep this video under 15 minutes so that you guys are not getting too much screen time. So we're not, drying your eyes out. anyways, here we go. Yeah, I want to keep you guys active too. I know some of you are enjoying your time at home, and if we can get this done fast, you can get back to activities, right? And here I go rambling away. So one thing here that we want to talk about are sets, and what sets are in regards to multiplication and their like relationship. So the best way I can think of drawing this is, say we have these cars. They're going to be the worst cars you've ever seen drawn, okay? This is it's like a little car. I don't know, some car. There we go. It's a funny car, but that's what it is. And we have 3 of these cars. These great vehicles. Sean Engineering built them. You know, they look like almost like the Tesla truck. You know, there we go. Perfect. So, say you have these 3 cars, and inside of them we have 5 people in each of them. So we just know that there are 5 people. So this is kind of like a set, you know. A set would be this one here. And if we said the number of sets would be the number of cars, right? So, and the number inside the set is 5. So for every 1 car, 1 set, we have 5 people. So this comes up in one of your questions, which we'll get to. But this is basically the same thing as saying 5 times 3. Because when you say 5 times 3, basically you're saying that you're either saying that you have 3 or 5 groups of 3 or 3 groups of 5. So you're basically saying I have 5, 5, and 5, which equals 15. You know, if you add these together, 5, 5, 5, that equals 15. This equals 15. So you get the idea of sets. Now, this part of the work looks at sets. So we have the total number of things, and then you have the number of sets. So that would be the number of like cars or boxes or however you want to look at that. And then we have number in the sets. So that would be, say if we had cars, the 5 people in the cars. So this comes up in your book as well. So one of the first ones, which I think is, we'll just say it's A, it tells you P, and then it gives you here a 5, and then I know some of you will be upset that my 5s don't look like 5, so is that better for you all? And then we have the 2. So how are we going to figure out the total number of things if we have the 2 parts but we don't have the whole? Well, I'm glad you asked. So we bring it down here to do the equation. If we're trying to find out P, which is the total, and we have the 2 parts, which are these, so we talked about parts in a previous lesson. We have the 2 parts. We can find the total by going like this. 5 times 2, and voila, you'll find it. P is equal to 10. And there you go. That's so, well, sorry. Yeah, you get the idea that I should put a P on this side, and then that is 10. And wazam, there we go. Now, if I instead, I'm like, oh, well, this one has 12, 4, and P. Now, this is a whole new thing. Now we have the total. We have the biggest number, kind of the largest number, you could say, if we go back to the other side. So this is when everything is added together, and we have part of the other, what goes into that 12. What are we going to do to find the other part that goes into that 12? Well, I'm, again, glad you asked. So we'll call this B, and I'll write a B here, and then you will see the magic of math. So we can write this again, like 12 equals 4 times P. We got a bit of a problem here. This doesn't, work out. What are 4 P's? We don't know. Instead, we can write this out as 12, or P equals 12 divided by 4. So here's how that works. That if you're missing one of the parts, but you have the total, you can divide that 12 by the one part, and you'll get the other. So in this case, this one would be 3. So P equals 3. But what happens if instead of the 4, I said, oh, well, maybe I just say 12 divided by 3, because maybe we got the 3 instead of the 4, and the 4 in this case had the p, and then we had a 3 there instead. Well, you'll get the cool thing here is, I'm just going to bring this up because we're getting close to the bottom of the camera here. We would get p equals 4. Oh, wow, right? And that's that number. Bam. So that's pretty cool, right? So when we're going from the bigger number, right, the large number, we have the total, and we have one of the other parts. We can get the other part by dividing. And this is kind of similar to, remember when we were working on the larger number. If you're trying to find the larger number and you have the smaller number and the scale factor, then you can multiply those together. But if you are given the larger number and one of the smaller numbers, then you have to divide to find the other smaller number. And this would be the same as in the last part. So that's all quite interesting. So I think for now, I'm hoping that this gives you enough to work with to go and tackle the problems. If you have any questions at all, please just tell your parents to get in touch with me, and I can try my best. I'm also hoping to start up a way to reply to you directly with your questions, maybe with an on video call of some sort, or a live YouTube video, so you can ask your questions live and I can do the question for you or with you, right, and show you how it's done. So anyways, we'll go from here. For now, this is what you get. Anyways, I'm happy to keep providing you with these videos, and I just hope you're all having fun. Oh, and the poetry, man, they were so good. So I was amazed by so many of the poems. Like, oh, I wanted to make almost read some of them. Maybe if you guys tell your parents if you like them that much, I can read them. Did I get marker on my table? What? Okay. Hey, anyways, cheers, my friends. Bye-bye.